Miko, so we're going to talk today about a combination of permissions, authorization, and troubleshooting in cloud-native applications.
Yeah.
It's a very actually interesting intersection. If we kind of dive in, the first thing that comes to my mind thinking about it is just being in the cloud-native space. What challenges does that bring to the table as we're thinking about permissions and building apps?
First of all, I think it brings so many challenges in all kinds of perspectives. In authorization specifically, it makes it really hard to understand what's happening, when, and who did what. That's exactly what we're going to talk about, along with some best practices on how to mitigate the effects of these issues.
Right. So we'll be talking a lot about the characteristics of cloud-native apps and how you address them. But first, maybe we should, before we start talking about permissions, maybe we should kind of cover the basics of what it actually means when we say permissions. So permissions or access control or authorization is part of a larger space called IAM, Identity Access Management, It starts in identity management, so things like Okta, Azure Active Directory, where you manage the identities on the organization side and from the app builder perspective, the customer side. And then you move to authentication, things like Auth0, Cognito on AWS and other solutions like that, where you focus on identifying who's at the door and deciding if you're letting them in. And then you finally arrive at the third step, which is the most complex one, authorization or access control, as we said before, where after you've at authentication identified who's at the door and let them in,
what can they do?
What can they do now when they're within the house? Can they sleep in your bed? Can they eat in your kitchen? Can they set your room on fire? Please don't set this place on fire.
Oh, man. But correct me if I'm wrong, it's not only from the user side, it might be also machines or anything that can connect to a system, and that is some kind of identity you need to manage and authorize to do something.
Exactly. So it's both the human actors, but more and more it's becoming more automated actors. It's automated agents is part of the solution we're building. You can think about the microservices that you have within your infrastructure in Kubernetes.
Talking one another, maybe CI/CD, some kind of automation.
Right. Can be third-party services that you're integrating in, coming in with webhooks and stuff like that. And it can also be automated agents acting on behalf of your customers. More and more applications are acting within applications for our users. So think about things like Zapier and IFT and stuff like that. Machine learning agents in general are becoming critical parts of applications and how users are using applications. Also, when we talk about users within the application, we should probably differentiate between the kind of different stakeholders that we have. So we have both internal and external stakeholders.
Internal can be developers, operation teams, security, product, compliance, and sales. And external might be your customers or tenants or accounts, however you can define it in your organization. Third-party system that you just talked about.
Exactly.
Even partners that you can connect to your system.
Auditors, so you have third-party players that are coming in to connect to your system just to check that the checks and balances that you have in place are the right ones.
So you need to authorize somebody to check your authorizations.
Yeah. So when I think of this, the first thing that comes to mind, like the bell that rings, is that this combination of things is super complex. It affects our entire infrastructure, it affects our entire application level, it affects our organization, like the developers working on this, the people we work with, and obviously our own customers. So getting this right or getting this wrong can have huge impacts on the quality of product that we're trying to deliver. And with that, there's nowadays a significant and dramatic change in how we think about building cloud-native applications with authorization.
So how did you do it like 5 or 10 years ago, before Kubernetes and the cloud-native boom?
Terrific question. So 5 or 10 years ago, what you had is nothing. So you had people just cobbling together things on their own, just dropping code in and hoping to have a working solution and implementing everything from scratch. Also, you had them doing everything proprietary. You had a couple of gems, like if you use a monolith solution, like I don't know, like Java, you'd have something in Spring Framework. So Spring Framework would provide
managing the authorization.
Right. So yeah, you get something built in, but that doesn't work anymore for microservices. You've got everything kind of spread out for you. Nowadays, it was hard from the beginning to build everything on your own, and nowadays it's insane.
Again, even if you were using the Spring Framework, which manages the authorization for you, it's only happening in that specific service.
Right.
And to be honest, you want something to be managed from the outside, managing everything from the top level.
Exactly. So especially when you go into microservices, if you try the same approach, meaning you take the same code and you replicate it for each microservice, as if it was the same piece of code, the same monolith, what would happen is that they'll start to drift away from one another, and you give it like 3 months and then you'll have chaos.
Yeah.
So that's how things used to be and why they kind of don't work anymore. And nowadays, luckily, we're starting to see a new trend. There are new best practices, which we'll touch on in a minute, and also new solutions, things like OPA, Open Policy Agent, is one of the leading examples. So OPA is essentially an engine that you can use to build a microservice for authorization. You load data and you load rules into it in a specific domain, specific language, and that can become your microservice for authorization, and it can scale out with your cloud native application. So that's kind of the difference between what we used to have and what we have today. There's also things like Google Zanzibar and other open source solutions. Another one that I like, obviously, is OPAL, our own extension of OPA, but we'll talk more about that in a minute. Yeah.
Can you talk more about what makes cloud native apps so difficult? What's the inherent challenges? Yeah.
So I'll be happy to touch a bit about that. Cloud native brings all kinds of issues into your production systems and applications, mostly being being distributed, which means that you have a lot of different services doing multiple things that might be connected one to another, talking one to another. And this being a fact, it makes it that you have a lot more changes coming in into your system and application. Everything, you're kind of changing a bit your way of working to be more agile and making a lot more changes, a lot more
updates, or like it becomes more dynamic. You have like CI/CD. Everything is changing all the time. It's not like one component you deploy it like once a month. Everything is constantly moving.
And let's take, for example, like you have a customer that complains that is trying to access a menu in your application and he cannot access it. Where do you start troubleshooting that issue? What kind of permission does he have? Where does it even start from? On what service did the request start from? Who did he talk to? What kind of the whole waterfall of actions that happened up to that point?
Yeah, with microservices and especially with Kubernetes, the elements as part of the decision plan of who has access to what, there are a lot of enforcement points, a lot of different points where that access can fail. And when it fails, it's really hard to know at which point did it fail. So having the ability to understand and build your troubleshooting and build your authorization at the get-go to face that is super important, because otherwise you can get lost real quickly.
Definitely. I think there's a lot of stuff that you can do to mitigate the issues later on, some kind of best practices or a way to build your system and applications in a way that's easier to manage and troubleshoot along the way.
Yeah. And also it adds, the access control aspect adds a new plane for the applications you're building. So the aspect of building, maintaining, and upgrading your access control becomes more difficult, because now you have a separate layer, that separate microservice for authorization, for example, and you need to manage that on itself. You need to understand the different relations that you have. You need to start understanding What models are you working with? Are you working with RBAC, role-based access control? Are you working with attribute-based access control? And all those different things will change the way your system behaves. So for example, let's say you're using attribute-based access control, and you assign the attribute that only people logging in from Minnesota should have access. So now when your developers are accessing the system, they get different attributes if they're not from Minnesota. Exactly. So you might they will lose the ability of understanding what's going on if they don't have the whole picture of how the solution is built with authorization.
But not even the user, even the one who's managing the application will have trouble understanding why it's happening.
Right.
Like the more fine-grained control that you want to have in your access control, the more issues you're going to have troubleshooting when somebody's complaining.
Right. So it essentially becomes a point where developer access is essentially a tightrope act. You're trying to balance it. So you obviously don't want people to have access to things that they shouldn't have access to. Yeah, that's the basic concept that you want with authorization, right? Yeah. But what happens when things escalate? When there's it's 2 o'clock in the morning, things are not working, you've got PagerDuty springing up your developers to handle the problem, and they don't have the right access to work on the solution. And, or even worse, they don't have the right access to see what is the problem that your customer is experiencing.
Well, let's be honest, over the years, it's happened to me a lot of times.
How many times?
Oh, well, at least 30.
At least 30, okay, yeah, it makes sense. So that's one part. You're limiting the access, so you want it to be tight, but on the other hand, you want to enable your developers, but also your salespeople, your support people, to be able to work with the system with the right access, with the right ability to see what's going on. And if you don't have that, well, that just means you're gonna suffer. So
at the end of the day, when somebody's gonna wake up at 2 a.m. to try to understand,
they're gonna suffer anyway. Yeah.
They're gonna suffer anyway, but in this way, you're gonna suffer too, because you're gonna have to answer the call and help them get the access they need to have.
Right. So this becomes a significant challenge, and also the data that you need now is becoming more advanced. Maybe you want to talk a bit about.
Of course, yeah. So when you're talking about troubleshooting, you're talking about information. What information can you get in a relatively short time span to troubleshoot the issue as fast as you can to make your customers as happy as you can?
Right.
And it starts from building your application right, having the right metadata or information on your services, on your cluster, on your even logs or audit logs. Mm-hmm. It can be, it depends a bit on how your organization is built. If you're working with users, specific users, or with accounts, or if you have your access control based, if it's role or permission or attribute based. Mm-hmm. And it makes it a bit harder to troubleshoot if you don't have all the data from the get-go organized, and you need to get as fast as you can to understand what is the issue, where it happened, when it happened.
Yeah.
And if you have all that information, it becomes a lot easier.
Yeah, and it's also important to understand that with authorization, the data plane that you need to work with is really expanded. Yeah. Just think about all the things you need to connect as part of an authorization process for an application. Let's say you want something simple, like only users that have paid for a feature should have access to that. So that data, that doesn't sit in your database. That now sits in a third-party solution like Stripe or Rapid or Chargeify. So now
they need access to know if somebody.
Yeah, so you need that to be synced with your application. You need that to be synced with your authorization layer, and you need that to be synced with your monitoring, auditing, and logging tools, because otherwise you'll have gaps in your information. And if you don't plan for that in advance, the chances of getting that right are essentially zero.
Zero. I think the biggest gap that happens when you work with third-party services is that every time you have a hope in your data, in something that's happening, right, the data is changing a little bit. And a third-party services might refer to your user with a specific ID. When it gets to your system, it's going to have the email.
Different ID, right.
When it gets to another service, it's going to have another ID. how do you keep track of all that?
Yeah, so you need to keep track of that just to get authorization right, so you don't have gaps, so you don't by mistake give people access that they shouldn't have, or also a bad thing is not being able to give them access. But as you say, it's also important to be able to have a unified picture.
Yeah.
So when you come to troubleshoot things, you can speak a unified language.
Exactly.
Otherwise, it's like the Tower of Babel and everything just falls apart very quickly. So I think what we're already beginning to see is that planning here and building things right from the get-go is super critical.
Not to say that you cannot, if you're already going in a company for 2 years and you have an authentication system already set, you can change and make it better.
Of course.
But
also, I never encourage people to like just throw everything out the window and start from scratch. That's a bad idea.
You can do everything gradually, but it takes time.
Yeah, especially if you have something working, that's great. But a lot of times you discover that you need to add more things, and as you are adopting new technologies, adopting greater scale, you end up having to change. And when you do those changes, it's important to keep in mind the challenges and also the best practices that one can apply to not fall into the pitfalls that we're kind of mentioning here.
And also that this change, this is the exact point something could fail.
Right.
Which is kind of scary.
Yeah, it's super scary. So also people probably shouldn't go about changing their entire authorization infrastructure in one day. It should be a gradual process, and they should do it with clear goals in mind.
Yeah.
Go from the feature that you want to implement, identify the capabilities that you want, and then gradually upgrade. Another example here that comes to mind here, and things that people often don't think about that they'll need to do, and kind of touches on the troubleshooting aspect as well, is impersonation.
What happens when an issue get in contact with a customer and you cannot understand what happens to it?
Yeah, so the customer, through your authorization layer, they have a lens, they have a filter where they're seeing the system in a specific way that is unique to their tenant and unique to their user, unique to their system. And now when you're logging into the system as a developer,
everything works right. It's like magic.
Yeah, it looks great for you, but it's not the same for them. And that can be both for like bugs, but also user experience issues. So impersonation is a feature that can be critical, and getting it implemented. So maybe I should clarify. So impersonation is the ability to see the system through the eyes of another user, not become another user or log in as another user, because that's a vulnerability. That's a security issue.
It's like sometimes when you contact the support of some kind of service and they ask you, give me permission to become you for 1 second, just to see what you're experiencing.
Exactly, exactly. So when you do that, you don't give them your password, because that would be a big no-no security-wise, right? But you do have something built into the system that enables that context view, that view as option, if you want to maybe talk like Facebook. And that can be critical both for your support and professional services, and definitely for resolving bugs and issues in the system itself. So I think we kind of painted a very gloomy, very painful picture here that I guess if you don't invest time and efforts and think about it, when you build authorization nowadays for cloud native applications, you'll be fucked, pardon my French. So what can we give our audience as kind of tips or best practices so they won't be too afraid, so they will, and when they decide to do this eventually, and they will, what can they do to get this right?
Awesome. So there's a lot of things that you can do to make your life a lot easier when troubleshooting and understanding your system. Keep in mind that you don't have to do everything to actually, for it to be useful. Right. You can start with something, see how it helps you, and iterate on the process and understand what exactly your system needs to troubleshoot efficiently. First of all, let's start with the information that you might need. If we speak from Kubernetes or the distributed cloud native system that we have nowadays, tags, annotation, labels, and that are properly handled, let's say, or that you have in your logs even, that everything is connected together in kind of a unified language, makes it a lot easier to understand what's happening. It might be a service name, a cluster name, what account is currently doing an action in your service.
So have that connected into your like annotations in Kubernetes.
Yes, yes. Have everything labeled properly. If you have a deployment of a database, it needs to have what version it is, what's the name of the database, which kind of environment it is on, maybe which user has done a certain query, so you can understand exactly who has done what.
So context, annotations, maybe connect this with your tracing.
If you have tracing, that's even better. Tracing gets a lot harder to maintain when you have a lot of code, but it's one of the most important parts of monitoring and troubleshooting, I think.
Right.
Would you like to enlighten us a bit about policies and authorization in that regard?
Yeah, definitely. So there are a lot of, nowadays with the new technologies and open source that's coming up, there are a lot of best practices that if you stick to them, will solve a major percentage of the problems before even you get to troubleshooting. And when you get to troubleshooting, will make it easier for you. I think the most important one, with the one which also was kind of championed by OPAL, by Open Policy Agent, which is a CNCF graded project, is decoupling policy and code.
Can you start a bit with what is OPA, like in a few sentences?
Yeah, so OPA, or Open Policy Agent, is essentially a agent or microservice written in Go that you can use to create a microservice for authorization in your system. You load data into it, JSON documents that describe your world picture for authorization. For example, your list of users, their roles, attributes about them, which departments do they belong to, the different services that you might have. And you load code into it in a domain-specific language called Rego. And that, as it becomes part of OPA, you can then come to it and ask it queries. You can say, this user is now trying to access this file.
Can it do that?
Can it do that? And OPA will tell you yes, no, or give you.
Is there a maybe or?
So it can give you, it can return data. So it can say, it can give you, for example,
like a partial access.
Yeah, so it will, for example, you can use it to create a subset query. It will give you a query that you can use against the database, filtered, that will only return relevant data that user can see. Or you can query the database and then ask OPA to filter the data, so it will clean out sensitive information, for example. So there are multiple ways to use OPA. At the end of the day, it's an engine running code. By the way, if you're familiar with Prolog or Datalog, it's based on those kind of technologies. So now when we understand OPA, by the way, there are also other solutions that you can implement a microservice for authorization, things like OSO or Google Zanzibar implementations like ORY, that's ORY. But the main player today is really OPA. So you end up creating a microservice for authorization. And the main thing you want to do there is decouple your policy and code. So you want all the code that handles authorization to be exclusive to your microservice for authorization, to OPA in one example. That way you don't have that code replicated across multiple microservices.
Which is deployed once and everybody communicates with it to understand what.
Also, you can use that once you work that way, you can apply GitOps. You can have a specific way where you hold your policy as code in a repository and you go through tests and checks, and then you can gradually deploy it into your microservice for authorization. If you do it otherwise, you'd end up having to shove code into different microservices and you have them coupled. So every time you change a different part of the application or you change the authorization, then you have to change everything. And that will obviously be very painful. So decoupling policy and code is probably one of the most important best practices that one can implement when you're doing cloud native permissions for your product.
Another thing that when you work with authorization, you sometimes want to update things on the fly. Because what happens if you need to omit access from some user right this moment? You don't want to spend the time with the CI and the test and deployment and waiting for your code to become available in production. You want it to happen now.
Spot on.
Problem with that is when things happen on the fly, kind of live, without any kind of, let's say, audits, it becomes a lot harder to understand what changed exactly. How do you keep track of these changes?
So you're touching on two things. One is the importance of having things work in real time. Especially if you're working in the application layer and not in the infrastructure layer, that becomes critical because users want to change things on the fly. So first of all, you need, when you're building authorization, as you pointed out, you need to plan for real time. Otherwise, if you try to add that later, it'd be problematic. So you need to keep that as a best practice. Think real time for authorization from the beginning. And then you want to have a system that enables you to have kind of transparency or ability to see what's changing. You want the ability to listen into the events that are propagating through your authorization system. So you want to connect
dashboard or back office that you can manage and see what's happening.
Yeah, so you want two things. One, a way to control how you push in new policies and new data. So that can work with GitOps. So a lot of people think, oh, if I'm working with GitOps, that means that it changes only when I deploy things. That's
not always true.
That's not always true, exactly. So you can have a GitOps channel that translates into a real-time channel. So you push into Git and you have something listening there and pushing that in as real-time updates into the system in live, but you still enjoy the GitOps pipeline. And obviously you want something that kind of enables you to manage it all. And so that will be like a back office or an audit log interface on top.
But now I'm beginning to think people that can change the authorization live right now.
Right.
How do you manage them? How do you manage who can change the authorization?
So it becomes recursive. So you have authorization for your authorization.
But who becomes the big administrator of everything?
Yeah. So that's a decision that you need to kind of make early. You need to decide how you implement the authorization for your authorization. The basic way to do it is to do it in a different level. So you have the authorization running in the application level, and you have authorization in the infrastructure level, enforcing access to that. So for example,
kind of a really small subset of people that you can trust.
A subset of people or a subset of rule or systems that you can go through. So for example, you can say, you can only change the authorization through Git. You can only change the system through a specific interface. Which has
its own enforcement, like code reviews and checks.
Exactly. So you want to have a pipeline that controls how you do changes. So that kind of connects to the GitOps approach or policy as a code approach that we mentioned before.
Which is kind of nice because if you do GitOps, it kind of also gives you a history of what's happened and who exactly pushed the change.
Right. So to recap on that, so we want to decouple policy and code, enable them to be updated in real time. And when you do those updates, you want to be able to control them through a policy as code or a GitOps procedure. Then what you kind of already hinted on is what we provide to the other people in the organization, the back office or interfaces. So,
which is not necessarily as much information as possible, but quality of information.
Right, it's the quality of information. It's also the right interface for the right person.
Yeah.
So a developer would want one sort of interface. A DevOps engineer would want a different interface. A security person, different interface. Reports or dashboard, have it feed as audit logs or logs into their SIM. A product manager will want a different interface. So we already kind of listed the fact that we have a lot of stakeholders. So we want to build that system, that GitOps layer. We want to connect different interfaces on top of it. So each user, we can provide the right experience for them. So everyone would be happy. And if we take that as a best practice, think about, we're going to build a back office. We're going to build interfaces for different people. It doesn't mean that you have to build them all at day one, but you want to think about building
all the people that's going to use it.
Yes, so that's another best practice. So we decouple policy from code, we enable changes in real time, we do those changes through a GitOps channel, and we provide interfaces on top for the different personas. And to wrap it all up and connect it with what you mentioned before, those processes will all have troubleshooting built into them. So we have logs, we have audit logs, we have annotations baked into all of those processes. So if we trigger something from a product manager interface, it will trickle down through all those systems, and we'll be able to see that that's what happened.
Which makes you think, when you're building an application or a system, what do you need to troubleshoot issues?
Right. So it's really important to keep that in mind. So when you're building each of those interfaces, you need to think, oh, this will now go from this interface into our GitHubs, and that will then go to this microservice that will then talk to our third-party system like Stripe. So you want to paint those pictures and think about how you annotate that process.
Exactly.
So when you go back troubleshooting it, you will have the ability to generate the right data that will give you the right answer. So you'll know which interface to use. So you'll know which users were affected. So you'll know if you need to apply impersonation. So you'll know if you need to go to a different source to look at where the problem is. Otherwise, again, it will get chaotic, as we mentioned before.
But even then, even if you have everything perfectly laid out in terms of information and access, and you've thought about troubleshooting in mind before building your system, the moment you have 10 different things that you need to go through when troubleshooting, it makes it almost impossible to understand and connect how everything happened together.
Right. So, like, I wonder if, like, do you have tips for how we can go from connecting GitOps to our data collection, or have like a tool where we can view the data in a way that is tailored for each situation?
Yeah. So I think the right answer for that is to have a tool that can unify all your information in one place and connect what's happening, and like see a timeline of, you know, what happened exactly in your system at that point in time.
Right.
That's exactly what we do at Komodor, which we'll talk about in a bit. But as you know, 10 years ago, people used to do it also. It just was a bit more difficult.
Right. So I think Komodor obviously is a great way to approach it, but I think in general, the mindset that you have in Komodor is collect that information that is relevant and present it in a unified way somewhere.
Exactly. Some kind of centralized system.
Yeah. So maybe people won't be able to build as a great product as Komodor to do it, but even if you just couple something together, even if you just have a database or a logging solution where you feed data into there, you'll be in a better situation.
For sure.
And if you're building complex authorization systems, you'll probably need to get into that at some point.
Yeah.
So it's also good to kind of plan for that in advance. So we kind of mentioned the real-time aspect of updates, and there I feel kind of obligated to mention OPAL. So OPAL is an open source project that I'm one of its maintainers. OPAL stands for Open Policy Administration Layer. It's obviously a play on OPA, but that's because it's meant to work with OPA, which we mentioned before.
Which is a requirement for it?
It's not so yeah. Currently, it only works with OPA. Maybe in the future we'll have it work with other solutions, but currently it's focused on OPA. And OPA today doesn't really have the ability of being updated in real time. The best it offers is a polling solution. You can tell it, you poll this server to get new updates for your policy, but that's not real time, and that is often problematic with the application layer because, as we said before, things change in real time. And user now invites another user. You want that to be applied now. You need emergency access. A developer needs now to be able to see the system from the eyes of a.
But if you're using polling for that access, if you poll every 1 second, 3 seconds, isn't that enough?
So it depends on what you're building. So first of all, if you poll that frequently, you might start facing performance issues. Yes. And also you won't be able to apply it to different parts of your stack differently. Right. So think about, it's no longer just one microservice that requires authorization. You have
300.
You have a sidecar. Ideally, with the way you work with OPA is you have a sidecar per microservice performing the authorization layer for it. So now if you have a lot of microservices constantly polling your server, it will come with a lot of cost, a lot of friction, and you need to, so you either slow it down or you pay a lot. Obviously a better option.
Always struggle to balance.
Right, right. So ideally you can avoid that with just having your updates in real time. So that's where OPAL comes in. OPAL sits alongside OPA, subscribes to a pub sub channel that's provided by an OPAL server, And then it can receive updates on changes according to topics. So each microservice can say, hey, I'm responsible for topic A or topic B. For example, I'm a microservice that works with billing. And then it subscribes to that topic. And when the billing information changes, the authorization data for that changes, only then it will be updated. And when it's updated, it will be in real time. Another thing that OPAL provides is the ability to aggregate data from multiple sources. So you can tell it, oh, a change now happened at Stripe. And then you can teach it through a simple Python module to go and collect data directly from Stripe. And in that way, you both solve the real-time aspect and the distributed data plane aspect.
Do you also provide some kind of, I mean, you called it administration layer. Do you provide some kind of admin area to manage all of these policies and real-time updates?
So we provide the ability to connect the policies to your OPA through Git repositories.
Okay.
So with OPA by default, you erect usually a web server that it will call, or you do it on S3 bucket or something like that. With OPAL instead, you can work with GitOps. So you load your data into a Git repository, and then when you want to change things, you just push them into Git. And that will trigger a webhook into OPAL that will propagate everything else across the different microservices. And you can have, again, each microservice subscribe to only different subsets of that Git repository.
Yeah.
Different policies within that Git repository. Yeah, so it distributes your policies through Git and provides GitOps for it, and also the data plane, as I mentioned before. Yeah. So OPAL is open source. Oh, but what it doesn't do like testing, and it doesn't do like a playground that you can work on managing the policy itself and author the policy itself. That's something that you find more on the OPA side with a service that the company called Styra. Styra is the company that built OPA. So they have a solution called Styra DAS, which provides all those capabilities to how you manage and write policies and build them across your organization in a more managed way. So OPAL only does the administration aspect of delivering the policies that you've written to
instead
the
of actually reinventing the wheel and inventing a new policy language and all of that.
Yeah, yeah. Yeah. So, and another thing that OPAL doesn't do is the interfaces themselves. It only provides the update layer, and the interfaces themselves and all the management components, like a user management screen and audit logs and the impersonation and emergency access, all of that, that's something that we provide as part of Authorizon as a SaaS service, which will be available as self-serve soon.
Oh, awesome. Is it available already today, or?
So everyone can subscribe on our website today, and it's already working. We've got the customers in production, but it's not open to the entire public. So you can sign up today, and we're addressing people according to the order that they signed up, and give them the gradual access into our early access program.
It sounds fair.
Yeah, it's one way to go around deciding who can do what. And for authorization, it's all about making decisions. And so in this aspect, we try to keep it simple.
That's true.
Yeah.
So from there, I want to jump a bit about troubleshooting and how you used to troubleshoot, 5 years ago when everything was a bit simpler. Imagine that you have an alert popping up, let's say in the middle of the day. So your Slack has a PagerDuty alert, and it tells you that there's high latency in some kind of service in your system.
Right.
What you usually do is, first of all, open the alert, try to understand where it came from, when it happened, how exactly severe the incident is, and the next step is to troubleshoot it. And what most people usually do is access all their monitoring tools and platforms to try to understand and piece together where the issue and what the issue is, to try to find the root cause and fix the issue. So you might be going to your log aggregation system, going to Kubernetes to check what's happening with the pods. Is everything healthy, or is something just crashing? going to review metrics and dashboards on your Datadog or Prometheus system, checking your CI. Maybe somebody pushed a change and something was deployed. I don't know.
Yeah, or propagated as an update into something like OPAL.
Yeah, for example. There's maybe some incidents that I find myself with 20 browser tabs open with a multitude of different tools, trying to understand and piece together
what happened,
what is the root cause of that thing.
Right.
And at Komodor, that's what we experience a lot of years working at different companies and what we're trying to solve today, of bringing a unified view of all your services and systems into one system, basically.
Right.
One system that can show you exactly what happened from all your services, from GitHub, Kubernetes, PagerDuty, Datadog, and all of that, and show you an exact timeline of what happened that triggered something on another service and caused your application basically to be down or have high latency or any kind of other incident. I think the most important part when troubleshooting is understanding how something affected your application. It might be easy to find a log or some kind of dashboard that shows you this is bad. It's easy to see. Okay, this is bad, but what is bad? Right. What exactly happened? Who did it? Why did it happen? That's all kind of questions that may take you, I don't know, 2, 3, 4 hours to understand.
Which can be very costly hours when it's 2 o'clock in the night.
Yeah. Think of maybe you're running a credit card or payment solution. If you're down for 2 hours, that can go up to millions of dollars.
Right.
It's these incident times are critical. You might have also the need to stay in some kind of SLA that you agreed on with your customers.
Right. And then you get fined for not being on time.
Exactly.
Yeah.
Yeah. So what you might be able to see on Komodor is, first of all, kind of a service catalog that shows you exactly the state of your cluster or all your applications in one place.
So for example, in that, if I implement authorization, so I'll be able to see my microservice for authorization, my OPAL, for example.
Exactly. You'll see all your services, including all your sidecars and authorization services.
Cool.
And if you want to try to deep dive on one specific thing because it's currently not healthy or crashing or not working properly, then you'll be able to see all changes that happened up until this point with a connection to all your other third parties that you're using, bringing everything into one view and making it easier for you to understand what happened in your authorization services, what changed, or who gave permission to somebody. Maybe you even as a developer, you're trying to get access to some system to troubleshoot something, and it works, but the next minute it doesn't. Why was your access revoked?
Yeah, and here maybe I'll connect those kind of 2 dots I mentioned. Now when you change things in the authorization, so that's changing code, and that code can affect the entire system, and that can, because we needed to change in real time, it changes in real time. So we need a way to keep track of it.
Yeah, as you said with GitOps, that you have everything is policies and code, and everything is kind of automated. So you have a code change, you have a CI or some kind of automation that pipeline that deploys that change,
right? And
you have your service that is being changed. There's suddenly 3 steps instead of 1.
Yeah, and there are multiple layers, multiple solutions. Yeah, so as we said before, you need the best practice of tagging everything. You want to write everything down and mark it. But even after you mark it, you need a way to have kind of a single pane of glass where you can see it all together.
Exactly.
Cool. So obviously people can try and build it, but with Komodor, that's what you do.
I think every company tries and builds something like that.
Right.
The issue is that it's kind of a capacity issue, that it takes a long time to have something that is polished and good enough for your company and your use case when troubleshooting. And it's something that's hard to do.
And you have correct me if I'm wrong, like in Komodor, you have a lot of knowledge built into the system. Like it knows common issues, so it helps you find them.
Yeah, so that's one of the things that we do is that we don't just bring you all the data into one place. We try to give you insight on what is happening and help you out, trying to bridge the knowledge gap that some developers might have in difference with DevOps that might know more about the infrastructure and all the automation that's going on in the system. Cool. For example, if something is crashing, it's nice to see that it's not working, but you want to understand exactly what is causing that.
Yeah, makes sense. Makes total sense. We should probably start wrapping up. So let's do kind of a quick summary of what we talked about today.
Yeah.
So we talked about the different challenges that come in with trying to write permissions and access control for modern applications. So just the fact that it's cloud native, that makes it harder. And we should be aware of that. It's not the same thing as building authorization for monoliths.
No.
And we talked about how the data plane and the different multiple layers that we have make it more complex. And we talked about, what else we talked about? Help me kind of do the summary.
We talked about all kinds of people or tenants that might be using your system and platform, your authorization. We talked about how to track, monitor, log, and audit your system the right way.
Right. So now it's working differently and it has all those multiple layers. So now we need to think about how we do logging and audit logs in advance when we're building this.
Yeah. And to summarize all that, I think the Tightrope Act that you talked about earlier is
right.
A perfect metaphor for that. Is trying to keep the right balance between somebody having too much access and somebody not knowing enough.
Yeah, not having enough access to be able to even solve the problems in the system. So these are all things that we kind of covered that are challenging when we're building permissions for cloud native applications, and especially when we're trying to troubleshoot them. Yeah. So we need to be aware of them from day one. That's one lesson we kind of learned today.
The second lesson is what can we do to improve all of that?
Yes.
And first of all, decoupling policy and code, making everything separate and unified is a lot simpler on your system and on you.
Yeah, so you want to have the code for authorization separate from your core logic for your application. If you do that, you already save a huge percentage of the pain. Then you want to be able to update that in real time. You want to be able to do those updates, at least connected to a GitOps process. You want to be able to build interfaces on top of those processes.
But to be able to do all of that, you need to start with building all of that with troubleshooting in mind. How to build all of that so it becomes easier for you to understand and troubleshoot. And one part of that is having quality information as part of tags, annotation, and labels in basically as many spaces as you can think of. If it would be logs or Kubernetes resources or your authorization configuration, everything needs to be with quality information.
Yeah. So for our viewers, we have our slides both with the problems that we listed and the best practices. And also you're welcome to approach both myself and Michael to ask more about it. You can join our Slack community for OPAL, and you can there's contact sheets on Komodor's website. Yeah. And so we mentioned the pains, best practices on how to address them. And we also mentioned tools. So we have open source solutions like OPA and OPAL. And you also, obviously, maybe we mentioned it too much, but you also have tools that kind of help you build this end-to-end. Authorizon that can give you full stack authorization end-to-end, and Komodor that can give you the entire troubleshooting end-to-end. And each one of you can kind of choose what's the right balance for you. But if you know the problems and you know the best practices, you can now decide how you want to go about approaching them and not wake up in the middle of the night realizing that you have a gaping hole that you didn't take care of.
That is the worst.
Yeah, awesome. Mikael, thank you very much. It was a pleasure doing this webinar with you.
Me as well.
And thank you everyone for watching.
Yeah, I think we're ready for some questions if we have from the audience.
Yeah, so thank you both. This was super interesting and thank you for that. So we only have a couple of questions. So I'm guessing that you are so informative and on point that nobody has any more to ask. So one question is, can Komodor and Authorizon integrate together? How do you integrate permission control with Komodor?
Right. So I can answer that one.
Yeah, go for it.
Komodor offers in addition to all the integration we do support officially, we do have a REST API that you can integrate with any kind of integration, also Authorizon, and send us data about what changed and what it is connected to. That we'll be able to show it along with your service.
Yeah. So maybe to double click on that. So even not just Authorizon, but also our open source OPAL.
Yeah.
So OPAL has part of it a pops up channel that creates those updates. It essentially creates an event for every change in the authorization layer. And you can tell it to push data or updates into another solution. So you can have OPAL notify Komodor of changes in the authorization layer.
Which is a great use case.
Yeah. So every time something changes, you can let Komodor know, and that can become your kind of main view on what's happening. In general, by having an event-driven channel, you can track things better. And when you have a unified single pane of glass, it's easier to track.
Yeah.
Next question.
Another question we have from Victoria. She's asking, how is Komodor different from kubectl? Why can't I just use kubectl to troubleshoot?
Well, Komodor offers you also kind of a view of kubectl. The difference is that not all developers or employees might have access to kubectl. And that becomes a big issue, is what we talked about, the tightrope. You want people to see data, but you don't want to give them too much access into production systems.
Right.
So
it's like the recursive aspect of authorization that we're touching on.
Yeah, but I think on top of that, what we do offer is also kind of a simpler view for people that don't necessarily have a lot of Kubernetes knowledge to understand their system with Komodor, along with obviously a lot of integrations that are on top of that.
Yeah, it essentially touches on the kind of best practice of interfaces and back office.
Yeah.
You don't only have developers, you have developers, DevOps, product managers, security, sales, professional services. Each of them need different tools. Not all of them can work with kubectl. Like you won't even give like a front-end engineer essentially the kubectl. It's not the right tool for them.
He might have the access, but he doesn't know how to use it.
Exactly. So you need a more tailored solution for each one.
And also, correct me if I'm wrong, Michael, but the history on kubectl, I mean, can kubectl show you like the history of all the changes, or is it only something you can do with a tool like Komodor?
So there are some tools that offer you kind of histories and revisions. kubectl in itself does not give you any kind of history. If you use Helm or Argo CD or other kinds of CI and CD tools, they might offer you history, but in a kind of a raw way, which is really hard to understand troubleshoot from.
Makes sense. Makes sense.
Good. And last question we have, and I think this one goes to you, or how does is Authorizon offering an end-to-end solution? Is it something that you can just copy paste?
Yeah, so that's essentially the idea. So unlike the different building blocks that you can use, like OPAL and OPAL that you can build on your own, with Authorizon, the idea is that we cover you end-to-end. So we give you both the infrastructure, the back office and interfaces that you need, and for your own management and what you need for your customers. So you get both things like a SDK that you can embed into your code and do like is allowed, who can do what, you can do and implement an enforcement point. And you can do, on the other hand, you can have a policy editor that your product manager can work with, decide who has access to what in a kind of a low-code, no-code fashion. And your users get a interface that you can embed in, like an iframe or React component, or you can connect to the API. They can get like a user management table where they can invite themselves, invite other users, assign roles, and you can get all of that working, and you just need to copy-paste a couple lines of code. And you don't need to think about how you connect everything, because we do that heavy lifting for you.
Amazing. We don't have any further questions, so good job, guys. Do you have anything else to add before we wrap this up?
I had a lot of fun and looking forward to doing another event with you guys.
Yeah, thank you so much for me.
Awesome. Thank you, Mika.
Likewise, so thank you everyone for joining us, and we'll see you on our next event.
Bye everyone.
Bye bye.